Hello everyone. Today we'll be looking at significance tests about hypotheses, and we will be looking at means. As usual, we are first going to do a recap of the major concepts needed to find the hypothesis test for population means. So once again, what's an hypothesis, the statements, the analysis, the test statistics, and the p-value. Well, as we said, the significance test is basically trying to use a test to make inferences about a population. And in this one, basically what we're doing is we're testing a claim or a hypothesis about a population being plausible. Well, in order to do that, we use a sample data, a random sample data, to summarize the evidence about a hypothesis, which is basically a claim being made here. For the hypothesis, we need two things. For every test, we need two hypotheses. One is called the null hypothesis, which is denoted by H sub 0. It is basically saying what we are assuming to be true initially. The second hypothesis in the significance test is the alternative hypothesis, which is denoted by HA. This is the one which challenges the status quo. It is a new idea, which states that the parameter falls in some alternative range of values. Now, how do we write it down? The basic part in a hypothesis is you're going to be working with parameters, that is the population. And in this parameter, it can be either a mean or it can be a proportions for this class. And when you're doing a null hypothesis, we are basically saying this parameter is equal to, this is very important, guys, to some hypothesized value. Whereas the alternative hypothesis have three possible scenarios for us. One, the parameter is greater than the hypothesized value, which we basically call a right-tail test or a one-sided test. A second form is the parameter is less than the hypothesized value, which is basically a left-tail test or a one-sided test. And the final one, the parameter is not equal to the hypothesized value. This scenario is a two-sided test. So a little practice of writing down the null and alternative hypothesis. Mean area of apartments in new development is advertised to be 1250 square feet. Now, a tenant group thinks that these apartments are smaller as being advertised. So what they do is they hire an engineer who is going to measure a sample of these apartments and to test their suspicion. We have to write the null and the alternative hypothesis. In order to do that, the first thing is we need this parameter. What is the parameter we're looking at? The parameter here is the very first word in the sentence, the mean area. So that means we're looking at mean. That's mu, is the symbol for population mean. Now, if it is the null hypothesis, it will always have an equal to sign. Okay, now what is that hypothesized value? The hypothesized value is the one which is also given in the first sentence. Let's read it again. The mean area of apartments in a new development is advertised to be 1250 square feet. That's the number which goes here. Okay. Similarly, the alternative hypothesis will also have this number. But what is the relationship between this mu and 1250? For the alternative is we have to go once back and read the sentences again. Now, the second sentence says a tenant group thinks the apartments are smaller. And that's the key word for us to know that's where the tenants are saying, something is not right. We feel it is smaller than what they're being advertised. And that's the key word, say alternative hypothesis means it will be a less than, because they are testing the claims, and that's where we are looking at. Okay, so once we are comfortable with writing down the null and the alternative hypothesis, the next step is we have to make the analysis. In other words, when we're doing a test of the null against the alternative hypothesis, we have to make the conclusion like whether we accept or we reject the null hypothesis. So if the sample, now this sample, guys, is this random sample data we take. We take the random sample data, and that data says strongly that the null hypothesis is false. Then definitely we're going to reject the null hypothesis. But if the sample data randomly which has been taken does not provide such an evidence that the null hypothesis is false, then we fail to reject the null hypothesis. That's the whole idea. We take a random sample data to make our conclusions, whether to reject or fail to reject the null hypothesis. Now, in order to do that, we need something called test statistic. Okay? What's a test statistics? Now, this is a quantity on which the conclusion to reject or fail to reject is based. And not only that, we need is a p-value, which makes our life very simple, where it is a conditional probability which tells that the results we get from a sample data is as unusual as the observed statistics given the null hypothesis is true. Okay? Now, we are now going to apply it to the hypothesis testing, where means is the parameter we are going to look at. So when we are going to do hypothesis testing, we have a steps to follow. So these 7 steps are, the first thing is we have to figure out what kind of population characteristic, that is the parameter we are looking at in our hypothesis testing. Second, we look at is the assumption. Then we state the hypothesis. We select the significance level for this test. Then display the test statistics to be used, and then find the p-value associated with the observed value of the test statistics. Now this is coming from the random sample data, guys. And then finally we make our conclusions based on our p-values. Okay. Now let's look at what is the procedure for one population mean. We're only looking at one population mean, guys. For a quantitative variable, the significance test often refers to the population mean here, mu. The first thing is we have to make sure the assumptions are right. That means we are having a simple random sample. And the population has a normal distribution or a sample size which is large, say greater than or equal to 25 or more. The second step is we state the null and the alternative hypothesis, whether it is the null is always easy. It's the mean equals the hypothesized value, which is mu0. And then we have 3 different forms of the alternative. They are either right-tailed, left-tailed, or two-sided test. So once we have got these 2 under, then we look at the significance level. Now remember, the significance level will be given to you. Now 2 cases come up. Either we know the sigma, that is we know the population standard deviation. Then the test statistics is the z equals x bar minus mu sub 0 over sigma over square root of n. And we compute the p-value. But if the sigma is unknown, that means we're going to use little s as a sample standard deviation. And we're going to find the area that a p-value would be. Compute the area under the t-curve with n minus 1 degrees of freedom. In reality, we actually work in this scenario because we're making analysis about population. And so sigma is a population standard deviation. So in real life, we will not have a population standard deviation, rather we will have a sample standard deviation. So this is the one we will be, guys, using case number 2. And then when are making an analysis, we look at the p-value. If this is less than or equal to alpha, we say we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Okay. Now, when we're performing test of population proportion, no, we don't want proportion, it's population means, guys, sorry. Using a normal distribution, we are using n is usually very large. We will perform test of population mean using a normal distribution or a student's t distribution. Keep in mind The student's t-distribution is used when we do not know the population standard deviation is unknown. And the distribution of the sample mean is approximately normal. Now, let's go ahead and do some examples. The first example, a company with large fleet of cars hopes to keep gasoline costs down. And they set a goal of attaining a fleet average of more than 26 miles per gallon. And to see if this goal is being met, they check the gasoline usage for 50 company trips, chosen at random. They find the mean to be 25.02 miles per gallon and a standard deviation of 4.83 miles per gallon. The question is this strong evidence that they have failed to attain their economy goal? Okay, now remember, when we start to find this, is there a strong evidence? That means we're doing hypothesis testing. They have failed. So that means we are checking the alternative hypothesis, and it's of the means because we're looking at average. You see the word average? That means we are applying the population means. So first of all, you're going to write down the appropriate hypothesis. The mean, the null hypothesis is mean equals 26, or the null is mean equals 26, and the alternative hypothesis is that mean is strictly greater than 26. Okay. Now, are these necessary assumptions? That means, is this simple random sample? Yes, because that word random is present. Second, is n large? Sure, it's a normal distribution because we have 50, definitely more than 25. So yes, the necessary assumptions are done. Now we want to apply the test statistics. Now remember, we only have the sample standard deviation and the sample mean. That means we will have to do the t-distribution over here. So it is the t-distribution with 49 degrees of freedom. So in that one, what is the formula there going to be? The formula for t is x bar minus, now that's the sample mean, minus the hypothesized value, mu sub 0, over s divided by square root of n. We get it to be minus 1.43. Remember, then we have to find the p-value. And because this is a right-tailed test, so that means our graph would be like this. This is our test hypothesis. Do you see that this t is minus? So this is the value we're looking at. So this is a right-tailed test. Okay. So that means is t greater than or equal to minus 1.4. And remember, the mean here and this one is minus 1.4. So we're going to be somewhere here. So the mean, it's this one. I'm sorry, it's not, this is a big number. Remember, minus 1.4 is on the, this is where the, the mound is, which is basically like the 0 we're looking at, and minus 1.4 is somewhere here. So we're looking at this area. So what do you find? The p-value is 0.921. Okay. What it says is that the p-value is definitely more than 5%, because 0.921 is strictly greater than 0.05. So as the p-value is greater than the significance level, that means we fail to reject the null hypothesis. So that means the null hypothesis, which was the mean, was of 26 miles. That is right. They're saying, oh, it has increased. No, it has not increased. So their evidence is not in favor. So their evidence is very, very, not the right one here. So in other words, their evidence is hoping that it will be more is not true for them. Okay, so in other words, the chance of obtaining a sample mean of 25.0 or less by natural sampling variation is 8%. Okay, the best one, guys, when you do these problems is use your calculators. And in order to do this one, you're going to use the t-test. So we don't have to go through all the formulas and worry about it. So my recommendation is use the t-test to do it. So what you're going to do is, I'm going to show you the steps and then we're going to take it from there. Okay. So for this problem, we're going to first click on Start, take the calculator to test. And we are doing the t-test. Remember, because we have sample standard deviation, take the cursor to 2, press enter. Now do not look at data. Go ahead and put it on the stats because that's much more easy for us. Press enter. Now mu sub 0 here is 26. That is the hypothesized value. The mean is the one which was given to us is 25.02. The sample standard deviation, let's see, what was it? 4.83. The n, then sample size was 50 and it is greater than, that's what they're saying. They're hoping to get it more. Okay, so take your cursor to greater than, press enter. Forget about the color, just go to the calculate and press enter. And here we get the values, the t value, the test statistics value, the p value, we get all of that. And clearly the p value is much more bigger than the significance level and hence we fail to reject the null hypothesis. Okay, let's look at another example. Is this, we would like to wish to test a company's claim that they produce bags of pretzels with mean mass of 454 grams. So what people, so we're want to test a company's claim. So we randomly choose 25 bags with these many these are the masses of each of these bags. So we would like to know at 5% level of significance, is there enough evidence to suggest that the customers are being cheated? What does this basically mean? That if it is being cheated, that means the mean mass is not 450, it is less than 454 grams. So that's what indirectly this question is saying. Oh, is the customer going to be cheated if it is less than 454? If it is more than 454, oh, we are all very happy. But cheating means you're not giving the right value. So here in this scenario, H sub naught is mu, the mean mass is less than 454 grams. So we would like to know, and we're assuming that the chosen bags are approximately normal. And we will verify the assumptions and test the model. Remember, we're going to use the calculator to do it. And I have actually done all these steps. Both these steps, like you go through all the little teeny-weeny steps, or you can just go ahead and use the calculator. So the first thing is the necessary assumptions right? Yes, because it's simple random sample. And n, as this background is approximately normal, we are good to go. So this is the null hypothesis. Remember, the null hypothesis mean equals. It's not H0 equals, it's mean equals. And the alternative hypothesis is mean is less than. Now, to find the appropriate test statistics and p-value, you can apply this formula. And you get that the p-value is strictly less than alpha. It's 0.01. or 0.921, sorry guys, this is a typo here. Okay guys, well this one is right, 0.01, and we are taking the alpha to be what? We're taking a 5%, so definitely this value 0.01 is less than 0.05. That means we are going to reject the null hypothesis, which basically means that the customers are being cheated. Okay, now that's one way of doing it, but remember we're going to just plug in the values in the calculators, and here is typos are here, not in the previous one. So it's 454, and what you need to do is, in order to get those values, guys, you have to plug in these, numbers and do the one variable test. When you do the one variable test, it actually gives the values, which comes out to be 450, and this one is 8.48, n is 25, and mu is less than mu sub 0. And when you do this, you get negative 2.36, and you get 0.013. Okay, so these are some typos, guys. So that's the best way. When you do these problems, my recommendation is please use your calculators to do the values. Okay, let's look at another example. Here, the mean top speed for cheetahs is assumed to be 60 miles per hour. 28 randomly selected cheetahs with top speeds were given below. And we would like to find a 5% significance level, that whether this data provides sufficient evidence to conclude that the mean top speed of cheetahs differs from 60 miles per hour. Remember, differs mean not equal to sign. So that's my alternative hypothesis, and the null hypothesis basically is mu equals 60. Now, in order to do the math, guys, you have to plug these values in your calculators, and you will find that the sample mean comes out to be 59.23. Do the one variable tab, and the sample standard deviation is 4.54. Okay. So when you do the math over here, guys, now here, because it's a not equal to, in other words, this is how our graph would look like. P-value here and P-value here. So this is the P-values, guys, we would be looking at. So it's going to be twice the value of one of them. Okay. So as we randomly picked up, so that means simple random sample, 28, definitely more than that, which tells us that our assumptions are satisfied. Then we have to find the appropriate test statistics. Remember, we are using sample standard deviation. Plugging in the numbers, we get negative 0.897. P-value, I'm using twice. Please keep that in mind. Okay, twice, because your alternative hypothesis is not equal to. So what we found is that our p-value 0.3776 is definitely greater than alpha, which is 0.05. And hence, we fail to reject the null hypothesis. In other words, the mean speed of a cheetah is 60 miles per hour. Okay, now that's all doing, by hand and doing these calculations. As I've always suggested to you guys, use your calculators. So when you're plugging your calculators, a stat, test, t-test, and then you plug in these numbers and make sure that you're having the input stats on. Let me show you again with the help of a calculator. So we're going to do this t-test. So the first thing we're going to do is we're going to click on stats, take the cursor to test, then take the cursor to number 2, press enter. The stats should be highlighted. Now the mean is mu0 is the hypothesized value. It is 60. Now the sample mean came out to be what? 59.23. That's when you plug in those numbers, do the one variable stat. 59.23. And then your standard deviation was 4.54. That's a sample standard deviation, guys. Oops, made a mistake. 4.54, enter. Now the sample size was 28. Oops, did something wrong. Okay, I'll have to start again, guys, it seems. Okay, enter. Well, I just must have, plugged in something. Everything is right. N is not 28. press enter, and then it's not equal to, it's already highlighted, press enter. Take the cursor to calculate, press enter, and here you are. T is negative, that is the T value, the test statistics, because we are doing a T distribution. Negative 0.897, P is 0.377. Okay, so we got the same answer as we had done actually by hand, doing all the calculations, plugging in the formulas and stuff. So my recommendation to you guys, just go ahead, use the calculator, make your life simple. Okay, thank you.